Hi Year 10, hope you're all doing okay. Let's go through page 12 of the ratio pack. Okay, number 1, the ratio of red apples to green apples in a basket is 1 to 2. Now that doesn't mean that there's 1 red apple and 2 green apples. That means that there are twice as many green apples as there are red apples. And so there might have been 10 red apples and 20 green apples, for example. But however many there were, it would have simplified down to this ratio. However, for the purposes of turning it into a fraction, we can just imagine there are 3 apples, if you like, and that one of them was red. So 1 out of 3 were red, 1/3 were red. Because even if it was that we had 10 red apples and 20 green apples, 10 out of a total of 30 is 10/30ths, which simplifies down to 1/3. So we can just treat it as if there were 3 parts, 3 apples, and one of them was red. What fraction of the apples are green? 2/3. Quite straightforward. Number 2. Exactly the same thing, just that we've got 3 parts to this ratio. So altogether, 4 plus 5 plus 2 is 11 parts altogether. What fraction of the counters are blue? So it says 4 parts are blue, so 4 out of the 11, 4/11ths is the fraction. What fraction are orange? Orange was the last one to be mentioned, so 2. So 2/11ths are orange. Cards in a pack are either orange or purple. 4/5 are orange, so 1/5 would be purple. Right, the ratio, this time we're going from fraction to ratio. So we're just going to look at the numerators here. We've got 4 oranges to every 1 purple. So 4 to 1 is the answer. And if you think backwards, the way we've done question 1 and 2, that would give 5 parts, 4/5 orange, 1/5 purple. 4 is presented slightly differently. It's very much the same sort of question though. It's just a bit of algebra being used here. So if the ratio of x to y is 3 to 7, which of the following statements are correct? Let's deal with these ones that have got x plus y in a bracket first. So x plus y will be the same as 3 plus 7, so 10. So this x plus y is 10. Is x 3/7 of 10? So is 3 3/7 of 10? Well, 3/7 of 10 would be dividing 10 by 7. That wouldn't give us a very nice number. Then multiplying by 3, it certainly wouldn't give us 3. So no, that one's not correct. B, x is 3/10 of both parts added together. Is 3 3/10 of 10? Yes, it is. So if we divide 10 by 10, we would get 1. Multiply by 3, we would get 3. Y is 7/3 of x plus y. So is y 7/3 of 10? Well, a third of 10 would be 3.3 recurring, times 7 would be over 21, so no. D, y is 7/10 of 10. I think we can see that that one's going to be the one that's correct. X is 3/7 of y. Now when it comes to comparing individual parts of a ratio, think about what you'd have to do to turn 3 into 7. So to turn a 3 into a 7, I would need to divide it by 3 to turn it into a 1, and then times 7. And that would give, that's the same as timesing by 7/3. Okay, so timesing by 7/3. To turn the 7 into a 3, I should change colour here, I would divide by 7 and then times by 3, which is the same as timesing by 3/7. So to turn y into x, times by 3/7, so yes, x is 3/7 of y. Okay, it is 3 out of what 1/7 of that is. x is 7/3 of y. Well, no, we've just proved that it's 3/7. Y is 3/7 of x. Okay, so to turn x into y, I need to times by 7/3. So y is 7/3 of x. So that's not right. This one is. Okay, slightly confusing, that last one, but it's about how you turn one into the other. Question 5 is a bit of a combination of topics, this whole MathsWatch clip, to be honest. Not really sure it needs its own clip, but they've also chucked conversion graphs in here. Right, so let's go through this first one. Okay, question 5, we've got a conversion graph, and it wants us to change between pounds and Polish zloty. So you can see those are the two currencies we've got on here. This is the other way to do it, other than just using a conversion rate. Change £20 into Polish zlotys. That's nice and easy because £20 is on our graph, and you can see so is its corresponding amount. So that looks to be about 100. Which I think from previous page of ZL, I think was the abbreviation. Change £90. So again, just going to use a line up from £90. See whether it hits the conversion line, which it does, and that's approximately 450 zloty. Problem with conversion lines is that they're not always really precise, so you can only give an estimated amount. Change 300 zloty to UK pounds, so this is going the other way. Still a value that we have. So that's 60, 450 zloty. Well, we've already done that one actually. That was the same answer as we had earlier on. That was £90. £50 into zloty. So again, we're going up from the pounds, and that looks about 250. £200. Now, these are the sort of questions that people find tricky. £200 does not appear on the pounds scale. It only goes up to £100. So here we have to do some scaling up. And fortunately, £100 goes into £200 quite nice and easily. You just have to double it. And also, it has a corresponding amount for Polish zloty, which also is on the graph. If £100 was there, but it didn't touch the line, for example, if the line was a bit more steep, and therefore we didn't have a point where we could see £100 reached, then we wouldn't really be able to use it. But since it is, we can use it. So £100 is 500 zloty. So I'm just going to write that down. And then it's just a simple case of scaling that up, doubling it in this case. So £200 would be 1,000 zloty. Okay, and the bigger the value you can use for this initial conversion, the better. For example, if I was to use £10 and then multiply by 20 later on, if I was ever so slightly off and said maybe that was 55 zloty, or just something other than 50, when I times that by 20, that would give me a very different amount to the amount I got here. Okay, so if you read off an error and then you scale up that error, it can cause you to go quite far wrong. Okay, let's finish off with this one. 800 zloty. Again, we don't have 800 zloty on the scale, but we do have 400, which is a handy amount just to double. So cross from 400, hit the line, and that's about £80. So I'm just going to write that down to begin with. 400 is £80. So 800 would be £160. And there we go.